Hello, my name is Julia Taylor, and today I'll be doing my CPR video for exam 3 over problem number 4, which is finding the magnetic field intensity of a hollow conductor inside a solid conductor. And so before I get into the actual problem itself, I'm going to first go into explaining the magnetic field intensity for a hollow conductor and a solid conductor separately. So for a hollow conductor, I assumed a hollow conductor with a radius r, and it has a current density on the outer edge. And so whenever you do these types of problems, you're going to start with this equation, which is finding the magnetic field intensity over a surface is equal to the current enclosed. And so on the left side, this equation, since you're dealing with a cylinder, it will always be 2 pi rho times the magnetic field intensity in the phi direction. And so when you look at this equation for when rho is less than r, since it's you'll have what we found up here, which is 2 pi rho and then times the magnetic field intensity is equal to, so then for the I enclosed, you're going to look at the current density times the area, which is pi rho squared, because rho will vary inside the conductor. So since this is a hollow cylinder, you need to notice that the current density on the inside will be 0, and so there will be no magnetic field intensity on the inside. When you look at the outside of the hollow sphere, you'll have the same left side of the equation, and on the right side you'll set the rho value to r, because it will be constant on the outside. And so then you can solve for a generic equation of rho is greater than r here. So you'll get the magnetic field intensity equals current density times r squared divided by 2 rho. And this is all in the phi direction with the units of amps per meter squared. So that's the system for a hollow conductor. Now for a solid conductor, you use the same equation. You'll get the same left-hand side of the equation. And about the same and the exact same right side of the equation. So for rho is less than r, you'll get 2 pi rho times the magnetic field intensity is equal to the current density times pi rho squared, where rho is less than r. And so you'll solve for the and so now, since it's solid on the inside, your current density, you'll use the current density that's on the inside, it's not 0 anymore. So you'll have an actual current density. You'll solve for this equation, and you'll get the current density times rho over 2. Now, when rho is greater than r, it will be the same thing as the hollow conductor, so you'll get current density times r squared over 2 rho. So that's like the general process of solving for the magnetic field intensities of each hollow and solid conductors. So now in this problem, when you have them combined, what I like to do is split it up into, let's say, 2 separate conductors, and then deal with it with different versions. So when rho is less than 1, you'll use this hollow sphere no current density expression that we use down here, and you'll get 0 magnetic density on the inside of the 1 meter hollow conductor. Now when rho is greater than 1, let's just imagine that there's no 2 meter conductor. You'll still have the current density of 2, which was given to us. And so you can use this equation down here, or you can just solve it normally, and you'll get a 1 over rho value for when rho is greater than 1. So then let's just imagine the rho is that there's no inside 1, and you'll just have like a solid you'll have a solid conductor where rho is equal to 2. So less than 2, you'll have the current density being 2 still, and you can solve it like the solid conductor, and you'll get rho, and then you'll get on the outside of that, you'll get 4 over rho, solving it the same way we did down here. And so now when you look at the whole system, having the hollow and the solid, you'll need to be careful in how you're adding them up or subtracting them up. So on the inside, you'll know the inside of rho is less than 1, it will always be hollow, always. So that value will stay at 0. So when rho is between 1 and 2, you'll have to pay attention to when rho is greater than 1 and rho is less than 2. So you'll always want to take the larger minus the smaller value. which is why here we did rho minus 1 over rho. It's taking the rho less than 2 minus the 1 over rho. So same thing here. When rho is greater than 2, you'll have to consider rho is greater than 1 and rho is greater than 2. You'll take the larger minus the smaller value, and you'll get 4 over rho minus 1 over rho will give you 3 over rho, and that will give you the final answer. That is my video for today. I hope you enjoyed it. Thank you.